Okay, today for lesson 16, we're going to be working with graphing again. So last time when we graphed, we used our factored form to graph. This time, it's going to look a lot like what we get when we complete the square. So we're going to be graphing using vertex form. So the nice thing about this is you can look at this and immediately pick out what the vertex is, and it's just going to make graphing a little bit quicker than what you guys experienced last time. But as you notice, we're using skills that we've developed. So at the beginning we use factoring form. Now we're going to use this completing the square form so that we can finish this. So what I want you to do for the opening exercise is I want you to graph these. So you'll have three different equations here. This one, and this one. So you're going to only graph it over the intervals -3 to 3. So what I would do is you could number these 1, 2, and 3. So for graph 1, here's your x and your y. So you're going to have -3, -2, -1, 0, 1, 2, 3. And then I want you to figure out what values would be there for 1. And then you'll do the same for 2, and then you'll do the same for 3. And then I want you to graph those points. Just stick to the whole numbers, and it shouldn't be too bad. So give those a try, and then come back and I'll show you the graphs. Okay, so I went ahead and set these up. So I'm using graph paper. I would suggest you use graph paper for this as well. So y equals x squared, y equals x minus 2 squared, and y equals x plus 2 squared. So I just wrote them out. I have them labeled 1, 2, 3, and now we're going to solve for this. So -3 squared is going to be 9, -2 squared is 4, -1 squared is 1, 0 squared is 0. 1 squared is 1, 2 squared is 4, and 3 squared is 9. So we'll go to the next one. So -3 minus 2 is going to be -5. So -5 squared is going to be 25. -2 minus 2 is -4, so 16. -1 minus 2 is -3, so -3 squared is 9. 0, we'll have -2 squared, so 4. 1, we will end up being at 1 minus 2, so -1, so it's going to be 1. 2 minus 2 is 0, and 3 minus 2 is 1, so 1 squared is 1. Okay, and then the last one here, we're going to have y equals x plus 2 squared, so -3 plus 2 is going to be -1, -1 squared is 1. -2 plus 2 is going to be 0, so it's 0. -1 plus 2, that's going to be +1. So we'll have 1 here. 0 plus 2 is going to be 2, so it's 2 squared is 4. 1 plus 2 is 3. 3 squared is 9. 2 plus 2 is 4. 4 squared is 16. 3 plus 2 is 5. 5 squared is 25. So we will graph this out on a coordinate plane. Let's see, we need to go over -3 and 3. So all of these are positive values, so I don't need to worry about the negatives, the negative y values. So I'm going to go with 1, 2, 3, 0, -1, -2, -3. Those will be my points. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can go up to 13. So we'll go up by 2. So 2, 4, 6, 8, and then 10, 12, 14, 18, 22, this would be 26. Okay, so now I'll graph. So my first points are -3, 9, so -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So I will graph this. So for this is going to be number 1. Okay, for 2, we have -3 is all the way at 25. So we're going to be all the way up here. And then at -2, we're at 16. So -2, we come down here. -1 is at 9. Oh, right here. 0 is at 4. 1 is at 1. 2 is at 0. And 3 is at 1. So this one will curve, comes all the way down, and begins to go back up. So this is going to be graph number 2. Okay, so then the last one here, we have -3, negative 3 is 1, -2 is 0. Oh, whoops. Not -2, 1. -2 is at 0. -1 is at 1. 0 is at 4. 1 is at 9. And then we have 2 at 16. And 3 is at 25. So all the way up here. So curves. And we're going to be going up. So there we go. So this would be our graphs for all 3 of them. So just kind of a couple things when we're looking at this, we kind of want to look at what they have in common, what is similar about the 2. So with all of these, all of them, their vertex is going to end up hitting on the 0. So when x is, or our y coordinate is 0, we're going to get the vertex for all of these. The other thing here is that we're getting, sorry, get that down. So we have x squared, x minus 2, x plus 2 in the parentheses. If you recall back when we talked about module 3, these are different translations. So when we have x minus 2 and x plus 2, these are translating. So if you remember, the translations looked like this. F of x equaled, and then you had, for this one we'll just go with a x minus h plus k. So when we had stuff on the inside had a horizontal translation. So horizontal. So on the inside it was horizontal, on this k would be vertical. So when we're looking at these, this is a horizontal translation, left or right, and this one's going to be a vertical translation, up or down. So for this one here, when we had x minus 2, so this one was graph 2. So 2, our vertex moved to the right 2. So when this was negative, our vertex moved to the right 2. When we had plus 2, our vertex would move to the left 2. So this again is just going back to what we talked about before with the vertex, or with translations. So this here we can start to use to identify where our vertex is going to be. So when we look at these, the other thing is, if we were looking for this k value, this k value would be 0. It'd be a plus 0 on the outside. So if we wanted to write that in, we could, plus 0, plus 0, plus 0. So we aren't moving it at all vertically, up or down. So what this is kind of telling us is that our h comma k is our vertex. So when we look at this, when we have a negative h, or it would be a negative and then our value of h, this h value then is going to be our vertex. So up here, when we have this -2, then this 2 is going to be where our vertex is at. That is our x coordinate, and that's what we ended up getting down here. Now our k value would be plus 0, so that's where we got for our y value. So then over here, we end up having plus 2. So in order to figure out what h would be, we would have to make this positive 2, plug it in here, and it would be a -2. So we need a negative and a negative to get this positive. So this negative, it moved to the left 2. And so then this would be at -2, 0, because we're plus 0. So this is a really nice way to graph. So this is utilizing that completing the square that I know some of you didn't really care for, but it's good because we can use it and immediately find the vertex instead of last time where we had to take the factored form, then you had to find the x-intercepts, and then you had to take the average of that, and then you had to plug it in, and yada yada yada. It was kind of daunting, and it took a while. So if we use the completing the square method or our vertex form, then we're going to find the vertex and we can graph from that point. So we are going to practice this on a couple here. So without graphing, we want to be able to identify where the vertex is. So some things to remember is it's y equals, it'll be a x minus h plus k. So just like it's up here, this is going to be the form that we're going to use. So if it's negative, we just take that number. If this becomes a positive h, then we need to take the negative version of that. So just something to keep in mind as we're working through this. So I'll do the first one with you for sure, and then I'll decide on B and C as we work through it. So for this one, without graphing, state the vertex of each of the quadratic equations. So what we need to look for is this h and this k. So I'll actually write this off to the side. So the vertex equals h comma k, just so that we have it there. Okay, so this one, our h value is going to be right here. That's 5. So we have 5 comma, and our k value will be this 3. And then for this one, our x plus squared, it's not being added to. There's nothing on the inside of the parentheses. So this is just going to be 0. Our h would be 0. And then we look for our k value. Our k value is on the outside, and that's going to be negative 2.5. So that's where we plug it, negative 2.5. That would be our vertex. So I'll just give you a quick second. Try this last one, figure it out. Okay, so if you're looking at it, we don't have a k value on the outside, so immediately we can say, hey, our y is 0. But we have this plus 4 on the inside. Remember, if it's a positive, we need to take the negative version of that number. So our x value is going to be negative 4. So that's how we do those ones. It's really nice. You can find the vertex immediately, and then all we have to do is plug in numbers around this 5. So we can plug in 4, 3, and then 6, 7, and we get our general curve. So then the next part, write a quadratic equation whose graph will have the given vertex. So this one is actually a fairly simple process. So it's going to be y equals, and we can just do x, and you'll do minus 1.9. So you're going to take this, you have the negative in front with the negative h. So negative 1.5 or 1.9 squared, and then this negative 4, we just stick that on the outside. So it's as simple as that. So all I want you to do is try doing it with the next ones for B and C, and then come back. Okay, so for B here, we have 0 comma 100. So it's going to be y equals, and we can just do x squared. X plus 0 would, and then squaring that would just be x squared. So then to get the 100, we have to add 100 on the outside. So then for the next one, for C, we're going to do y equals x. Since this is a negative, we'd have the negative out front, so it'd be negative and a negative. That'll change to a positive 2 squared. And then this 3 over 2, we just add it to the end, plus 3 over 2. So for this one, this would work. The other options that we could write is this a. So I haven't really talked about this a much. So if you were to remember back when we were talking about translations, this a in front, it's going to end up indicating our vertical shift. So changing the slope of the equation. So for these ones, we could actually change the slope of the equation and write many different options for these ones. Another option we could do is y equals, we would say negative 1, x minus 1.9 squared minus 4. It's going to have the exact same vertex, except now it's going to be opening up. So where this graph would open like this, opening up, this one would open like this, opening down. So this is just something to be aware of, that these values here in front can change, and we can get different slopes with the equation. Just something else to remember, that when the value in front is, say, negative 1, or actually, when it's going to be less than 1 or negative 1, so a decimal, 0.1, 0.2, something along those lines, that it's going to be shrinking. So the graph of the vertical wise, it'll shrink down. So it'll stretch when a is greater than or less than negative 1, so negative 2, negative 3, negative 2.5, things like that. Or a is greater than 1, and 2, 4, 6, 6.5, whatever. Then we're going to be stretching it. So it'll end up getting longer. If we're shrinking it, it'll end up getting shorter or smaller. It'll take many more x values to get to the same numbers. So that's just another thing to keep in mind as we're going through this. So that's just going to be something that you can kind of pay attention to, especially when we are graphing. That way you can look at it and be able to determine what's going on. We're going to look at this real quick. This is kind of a real-world application of the vertex form, and we'll just get going with it. So Caitlin has 60 feet of material that she can use to make a fence. Using this material, she wants to create a rectangle pen for her dog to play in. What dimensions will maximize the area of the pen? So just real quick, thinking about some dimensions, we could say it was 15 So 15 by 15. That could be a possible dimension. We get 15 plus 15. The side lengths would be 30 plus 15 times 2. You'll get 30 again. So that could be a potential one. We could also do, let's say, we could do 10 on one side. So 10 and 10, we'd have 20 total. And so we'd still have 40 we could work with. So it could be 10 by 20. So these are just some hypothetical side lengths. So we'll work with this and see which one would maximize it exactly. So if we let width, or W, be the width of the pen in feet, we're going to write an expression that represents the length when the width is W feet. So something to kind of think about, we have 60 equals, it would be 2W plus 2L. So we're going to use an expression to kind of solve for this, but it may actually be easier if we use an equation. So if we want to solve for L, figure out what this expression would be, the first thing we would do is we'd subtract 2W from each side. So minus 2W minus 2W. So we get 60 minus 2W, that's going to equal 2L. Then the last thing we'd have to do is divide both sides by 2. So we get, when we do this, this is like when we split the squares. We can divide each one of these separately. So 60 divided by 2 would be 30, and that'll be minus 2W divided by 2 will just give us W, and that'll equal our length. So for the next part here, so we have our width would be just W, and our length is going to be this 30 minus W. So if we want to maximize the area, this is the next part that we're going to do. So we're going to define a function that describes the area in terms of width. So we're going to have A, and that's going to equal, we're going to have W, so that would be the width, times 30 minus W. So that's what we would have found here for the length. So we did width times length. So we just substituted those in. So we took A equals width times length, and we just substitute in the values. So the other thing we can do is multiply in the 30, or the W, just so that we get it in a distributed form. So it's going to be W times 30, so 30W, and then W times negative W, so negative W squared. So for this one here, it says rewrite it in vertex form. So the very first thing is, to get to vertex form, we have to complete the square. So we're going to have negative W squared plus 30W. So when we're working with this, we want to have a positive 1 in the front. So the very first thing we're going to do is take that to the outside. So W squared, and this will now become negative 30W. Okay, then completing the square, for this one here, half of 30 is going to be 15. So if we were to use the box method, you would do 15W, 15W, W squared. So we have W times W, and then we'll have over here 15 times W gives 15W, W times 15 be 15W. So then 15 times 15 is 225. So then for this, we would end up putting this into the equation over here. So now we have negative W squared minus 30W plus 225. So that would complete the square. Now, when we work on this, we're going to have to subtract the value that we get in here. So we have 225, but it's going to be times this negative. Now, if we were to make that negative again, or multiply it by negative 1, it's actually going to end up being a positive 225. And you can also think of it this way. When you distribute this in, you get a negative 225. So in order to counter that, in order to get the positive value, or to keep it at 0, we'd have to add 225 on the outside. So it's a little backwards from what we think, but you have to do it because of this negative sign in the front. So if we reduce it down, we'll get negative W minus 15, and that's going to equal, and you also have the plus 225. And so that would be it in vertex form. We had to complete the square, and so now we have negative W minus 15 squared plus 225. So now, what are the coordinates of the vertex? So if we're looking for the coordinates of the vertex, remember that's the H, comma K. So we have negative 15, that's exactly how we should have it. So we're just going to take the 15 here. So 15, comma, and then the k on the outside is 225. So what are the coordinates of the vertex? We got it right here. Now interpret the vertex in terms of the problem. So when we're looking at this, what it's saying is the max area is 225. That would be the maximum area that we can make. So the width needs to be 15 feet. So if the width is 15 feet, then a length equals 30 minus 15, and that will be 15 feet as well. So our width and our length are also going to be 15. So for E, what dimensions maximize the area of the pen? It would be 15 by 15. Do you think this is a surprising answer? It may or may not be a surprising answer to you. Normally when you're trying to maximize area, the best area you're going to get is by creating a square if at all possible. That'll be the best size. That'll maximize it. This one, if you think about it, this would be 200. If you do 15 times 15, you'll get 225. So normally that's going to be the dimensions that are the biggest. So yeah, may or may not be a surprise to you, but that's all I got for lesson 16. It's not terribly long, and really we're just using what we know from completing the square. We're now going to apply it to graphing, and I think this will actually be an easier way to graph than most of you experienced with the factored form. So that's all I've got for you today.